Welcome, GeoTrig. This is section 2-3, Biconditionals and Definitions. The essential question is, when will you use the phrase if and only if? Let's begin. So if and only if. This is the key part of this lesson today. So we're learning about this statement because you're going to be using it a lot in proofs for geometry. So if and only if. One way we abbreviate this, and you might see me abbreviate this, is IFF. This you read it as if and only if. Just a way to shorthand things. Alright? So before we get into this, biconditionals. So if and only ifs are used for biconditionals. What are biconditionals? They're a statement that combines a true conditional and the converse. You know how we said if P then Q, like 1 or 2 lessons ago, and then you can do the converse, if Q then P? Well, the biconditional means that both of these statements are true. We can combine it. We write it with the phrase if and only if. So P equals Q, and then if Q then P, then we can draw this together, if P then Q, with 2 arrows going back and forth. Alright, what's a conditional? Conditional is if the sum of the measures of, so I have a conditional is if the sum of the measures of 2 angles is 180, then the 2 angles are supplementary. You know that's true. Alright, so if the 2 angles add up to 180, they are supplementary. The converse of that says if 2 angles are supplementary, then the sum of the measures of 2 angles is 180. Is that true? Well, yeah, because if I said they're supplementary, they're supposed to add up to 180 degrees. So both of these statements are true. So the biconditional says we can combine those to one statement and say 2 angles are supplementary if and only if the sum of the measures of the 2 angles is 180. So this just combines those 2 conditionals and the converse. So a key part of geometry is creating good definitions and when we want to identify or classify objects. And this is where biconditionals come in if and only if. So a key parts of a good definition is it needs to be clearly understood terms. It has to be very precise and very detailed. So, and this is the other thing, precision. Don't use words like large and sort of and almost. These are words that we use in language, but they don't actually mean something precise in mathematics. We need to use precision. We need to write, when we write an angle, we need to make sure that we put the points in the right order and we label it precisely so there's no ambiguity in what we're actually talking about. Another key part of definitions is they are reversible, and this is what we're talking about today. You can write as a biconditional. So let's do an example. Pause the video. Alright, let's try this. What are 2 conditional statements that form the biconditional? So you got a biconditional. A ray is an angle bisector if and only if it divides an angle into 2 congruent segments. So the 2 conditional statements that form the biconditional, well, the first one is if a ray is an angle bisector, then it divides an angle into 2 congruent segments. So if a ray, blah, 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 I'm going to shorten this, angle bisector, then, and the conclusion is, it divides an angle into 2 congruent, I'm just going to shorten that, angles. So that's the first conditional. Now the second conditional is just the converse of that. So we say if an angle is divided to 2 congruent angles, so if an angle divides into 2 congruent angles, then the ray is an angle bisector. Excellent. Let's try another one. Pause the video. Alright, so we have a definition. A quadrilateral is a polygon with 4 sides. Okay. Is this definition reversible? If yes, write it as a true biconditional. So, okay, quadrilateral is a polygon with 4 sides. Yep, that's the definition. So, is the reversible would that be if you have a polygon with 4 sides, then it is a quadrilateral. A quadrilateral. So if a polygon has 4 sides, then it is a quadrilateral. Is that true? Well, yeah, because anything with 4 sides will be a quadrilateral. So we can say, this is true. So is this definition reversible? We say yes. And since it is, we write it as a true biconditional. So this is using that if and only if. So we can say a quadrilateral is a polygon. Wait, no. We can say a polygon is a quadrilateral, if and only if, and I'm going to abbreviate that, it has four sides. So there you go. There is a true biconditional. A polygon is a quadrilateral if and only if it has four sides. The last one. Pause the video. All right, which is a good definition? So we got 5 of them here. Well, this should be E. So a good definition has to be precise, and it has to be, let's go back to those. What do we say? Clearly understood, it has to be precise, it has to be reversible. So I think the key here is, are these reversible? So the first one, a fish is an animal that swims. Okay, well that's clear. It's kind of clear to me, and it's talking about fish, but is that reversible? Is an animal that swims a fish? Not necessarily, because it could be a shark, and that's not a fish. So this is, nope, can't reverse it. This is not a good one. Not A. So, next one. Rectangles have 4 corners. Okay. If something has 4 corners, is it a rectangle? No, because it could be a rhombus. These have 4 corners. It didn't say they have to be right corners, they're just corners. So it's not necessarily a rectangle, so this is not a good definition. No. Giraffes are animals with very long necks. Is this a good definition? Well, the reverse of that, an animal with a very long neck is a giraffe? No, because it could be a brontosaurus. That's a dinosaur. So it could be a dinosaur. Or some other animal with a very long neck. So it's not necessarily a giraffe. If I said, hey, look, an animal with a long neck, you might think giraffe, but you might think a brontosaurus. So this is no good. Next one, the ring bearer is Frodo. Well, is this a good definition? Well, no, because Frodo, if you have a Frodo, is he always the ring bearer? And he's not, because he didn't have the ring. Bilbo had it first. And then he lost the ring a few times. So this is not a good definition. Last one, a penny is a coin worth 1 cent. So the reverse of that, if you have a coin worth 1 cent, is it a penny? Well, yeah, it is. So this is a good definition. We're talking about American currency here. So if you have a coin with 1 cent, it's got to be a penny. So if I said I had 1 cent in my hand, you know I have a penny in my hand. I don't have a quarter or some other kind of currency. I have to have a penny. So this is a good definition. That's it.